Good morning, students. Today we are going to see the subtopic global wind systems, trade winds, and Hadley cell. And also we are going to see the other subtopic, the western lights, cloud formation, and monsoon rains, storms, and hurricanes. So here what you need to understood is that what is trade wind, what is Hadley cell, and what is westerlies. The global wind systems and atmospheric phenomena, understanding large-scale wind patterns such as trade winds, Hadley cell, and westerlies is essential to explain how heat, moisture, and energy move around planet. So the driving force which makes you to move the heat, moisture and energy around our planet. Because of this, the wind pattern changes. Okay, because of this wind pattern, the rainfall occurs or there may be a drought. So you need to understand the movement of heat, moisture and energy in our planet. These systems influences weather, climate and ocean currents which in turn affect agriculture, water resources and disaster risk. So this all influences the trade wind, anti-cell and vessel ice. This system influence weather, climate, ocean currents which in turn affect agriculture, water resources and disaster risk. So the is essential. The what I mean to know is that what I would like to say is that okay, the heat, march, and energy movement around our planet is very important. We also examine cloud formation, monsoon circulation, storms, and hurricanes, and their links to climate variability. Okay, so we also could examine the cloud formation. Okay, so whether is a thick cloud, a vertical cloud, or cloud with the thunderstorm and things like that. What is the monsoon circulation, storms, and hurricanes, and their links to the climate variability. These are hurricanes and all. That is true, right? Right. Coming to the definition of trade wind, it goes like this: persistent, steady wind that blow from east to west. Underline the word trade wind moves from east to west between the equator and roughly 30-degree latitude in both hemispheres. The direction, okay, northern hemisphere and northeast trade wind, in southern hemisphere southeast trade wind. Northeast trade wind blow from northeast to southwest. What is northeast? You just divide the direction north, east, north, south, east and west, and north and east in between that one. So blow from northeast to the horizontally to the southwest. Okay, so southern hemisphere blow from southeast to northwest. So the trade wind is created by the cause for the creation and created by the movement of air from the subtropical high pressure belt toward the low pressure equatorial zone deflected by the Coriolis effect. What is Coriolis effect? Is a rotation. The earth is rotated from which direction to which direction? Is it from east to west or west to east? Actually, it moves in the clockwise direction, right? The Coriolis effect. Significance: historically important for sailing. Today, they influence the tropical weather patterns and ocean currents. So, the trade winds are historically important for sailing. So, the people sail through boat in the previous days, right? So, it's historically important. The trade wind is historically important for sailing. Today they influence the tropical weather patterns and even the ocean current. So, in the last class, we have seen the ocean current. Okay, how it moves from the tropical region to the polar region, and how it moves from the polar region to the again back to the tropical region. The warm air will move from tropical region to the polar, and cold air moves from the polar to the thing. Okay, so that's what we have seen in the last class. Coming to the Adley cell, the definition goes like this: a large scale atmospheric circulation pattern in which warm air rises at the equator and sinks at the air around 30 degree. So whenever it get warm air, that means from the solar radiations get heated up. Okay, so the warm air rises at the equator and sinks at around 30-degree latitude. The process, so there are four steps: Heating at the equator causes air to rise. Air moves poleward in the upper atmosphere. Air cools and sinks in the subtropics around 30° north south. South winds return toward the equator as trade winds. So the role, the transports heat from the equator toward the subtropics. So the transports heat from the equator. The heat transports from the equator toward the subtropics, keep in shaping climate zones like tropical rainforests and deserts. So the early cell and westerlies. Definition goes like this: prevailing winds that blow from the west toward east between 30° and 60° latitude in both hemispheres. So the direction northern hemisphere and southern hemisphere are both hemispheres. So in the northern hemisphere blow from southwest to northeast, southern hemisphere blow from northwest to southeast. So the cause for this, formed when air moves poleward from the subtropical high pressure belt and is deflected eastward by Coriolis effect. That means Earth is rotated. Okay, the Coriolis effect here means Earth is rotated. Because of that, the movement of wind direction, everything is also a factor. Okay, the wind pattern because of the Coriolis effect. Significance: dry weather systems in mid latitudes and influence ozone currents like the North Atlantic drift. So what I'm asking you to do is that try to take a map and see what is hemisphere, southern hemisphere, what is northern hemisphere, what is where the polar region. I mean, you know already, but I ask you to take a map and then see the direction, how the wind direction takes place from southwest to northeast and northwest to southeast. Because of that, how the heat energy is moving. Okay, and then how the wind direction takes place and things like that, so that you will understand a bigger picture on this. So by natural means the rainfall occurs, and by natural means the catastrophe occurs, everything by natural means of only. Okay, so please try to understand why this is occurring. That also we could be able to understand by knowing this theoretical knowledge. Okay, coming to the introduction to global wind systems. Global wind systems are the planet's primary method of redistributing heat and moisture from the equator towards the poles. They arise due to uneven heating of the Earth's surface by the sun. These winds are organized into predictable belts: trade winds in the tropics, westerlies in the mid latitudes, and polar easterlies at higher altitudes. So these winds are organized into predictable belt. Trade winds in the tropics. So trade winds, the definition we have seen. Westerlies, we have seen the definition in the mid latitudes. Okay, and the polar easterlies are at high altitudes latitudes. Okay, so their interaction with land, oceans, and topography drives seasonal climate patterns and long-term climate trends. Underline the word seasonal as well as long-term climate trends. This interaction with land, oceans, and topography. Unequal heating and atmospheric motion. The tropics receive more solar energy than the poles. Okay, obviously, poles will have a less because it has been tilted to 23° that you know already, causing warm air to rise near the equator and colder air to sink at the higher altitudes, latitudes. Okay, sorry. This temperature contrast creates pressure differences, driving large scale air movement. Earth rotation. Okay, Coriolis effect. As I told you, the Earth rotation takes place. Okay, let's say imagine if the Earth is not rotated and it's still stationary. Okay, then what will happen? As I told you in the last class, when there is no sun, what will happen? When there is no moon, what will happen to our planet? When the Earth stops rotating, what is happening to the planet? Just think of. There are a lot of videos available in YouTube. Okay, and what would be the effect actually because of one is not doing so? Okay, is regular. Operation. Okay, so Earth rotation Coriolis effect deflects these winds, giving rise to organized circulation patterns that help balance the planet heat budget. Trade winds overview. Trade winds are steady easterly winds found between 0° and 30° latitude in both hemispheres. They blow from the subtropical high pressure zone toward the equatorial low pressure zone. That means the wind flow from the high pressure zone to the low pressure zone, trade wind. Okay. They are driven by the early cell circulation and are deflected westward by the Coriolis effect. Historically, They are important for navigation, as I told you, and today they remain important, vital in regulating tropical climate and ocean currents. Trade winds are remain important in regulating the tropical climate and ocean currents. Trade winds and tropical Pacific. In the Pacific Ocean, trade winds push warm surface water westward, deepening the thermocline in the Western Pacific and rising sea levels there. This warm water supports intense convection and rainfall over Indonesia and northern Australia, while the eastern Pacific remains cooler. Okay, the trade wind, this warm causes the warm water. This warm water supports, okay, intense convection. Okay, intense convection and rainfall over Indonesia. Why certain part is raining? Okay, because of the wind condition. Okay, rainfall over Indonesia and drought also. This is because of the wind pattern only. Okay, this east-west temperature contrast maintains normal tropical weather patterns and marine ecosystems. Trade winds and monsoons. Trade winds transport moisture from the ozone toward land masses, fueling seasonal rainfall system such as Asian and Australian monsoons. When these winds reach land and are forced upward by topography, the moisture condenses into heavy rainfall. Their seasonal strength can determine whether monsoon rains arrive on time and in sufficient quantity, and insufficient, not insufficient, and insufficient quantity. What is ENSO? Okay, I will explain to you what is ENSO events. Okay, shortly. Okay, and trade winds during El Nino events. Okay, El Nino events is one of the ENSO events. Okay, El Nino events, trade winds weaken, allowing warm water to shift eastward, disrupting the normal rainfall pattern globally. This often leads to drought in Australia and India and flood in South America. Just imagine, so one area is getting flooded, another one is getting drought. Okay, that you usually see in newspapers. This all happens because of the wind patterns and things like that. Okay. In contrast, during La Nino events, stronger trade winds push even more warm water westward, increasing rainfall in Asia and reducing it in the Americas. Okay. Coming to the Adley cell overview, Adley cell is a tropical atmospheric circulation pattern with rising air at the equator and sinking air at about 30-degree latitude. So the definition you already seen on the Adley cell. It plays a major role in moving heat and moisture poleward from the tropics. This circulation is closely linked with the Walker circulation, which moves air along the east-west axis across the Pacific. Intertropical Convergence Zone. Okay, ITCZ, Intertropical Convergence Zone, is where warm, moist tropical maritime air meets and rises over drier continental air masses. So maritime, whenever it has been related with the ocean or ocean, all right. So this zone of intense convection brings heavy rainfall and thunderstorm, migrating seasonally with the sun. Its movement determines rainy and dry seasons in tropical regions such as West Africa. Okay, intertropical convergence zones where warm, moist tropical maritime air meets and rises over drier continental air masses. And air that rises in the intertropical convergence zone flows poleward at high altitudes before descending in the subtropics. This complete airly cell circulation and contributes to subtropical high pressure zones. These high pressure areas are associated with deserts and dry climate in regions like northern Africa and Australia. What you need to understand from all this is that, okay, what are the different types of wind patterns? Okay, how the wind patterns takes place? Okay, how the earth has been rotated? Okay, and then it has had a tilting position. Because of that, is all monsoons takes place. Okay, and also the rainfall takes place. This all because of the heat energy. Okay, and how the heat has been transferred, transformed. I mean, driving force because of the heat driving force. Okay, so all this happens. That energy and energy factors also need to be considered, as I told you in the first slide. Okay, so coming to the Walker circulation and descending branch, the Walker circulation is an east-west circulation. Okay, across the Pacific with rising air in the west and sinking air in the east. That's why I just asked you to take a map and then try to plot how the why this pattern arises. Okay, what is it? Then it will be easy to remember. Otherwise it's not easy to rewrite in the exam for your formative assessment, or it may be a summative assessment. So better you just take a map, global map, and try to see how the wind direction occurs, what is westerlies, what is a other trade winds, and so on. Is designing, okay, coming to here, is designing branch suppresses rainfall over north and south America and tropical Atlantic, contributing to dry conditions there. Okay, so just imagine, okay, one side is you have a long heavy rainfall, one side you have a what you call drought. This is not good, right? So if it is even, is okay, but the climate is also is not even, right? One side you are very cold, we find very cold, and other side is very hot, like a desert region or tropical region like India. Okay, so near to the equator, which we are people who are living. Okay, so if you migrate, the people who are migrating from Western countries to like very hot climate like Rajasthan, where you will have a what you call temperatures around more than 45 degrees Celsius. Okay, it is very difficult for them to survive. Okay, so the people around the globe will have a moderate temperature. Okay, so 26 or 27 is very normal. Okay, the people will could be able to survive. But if it is too hot or if it is very too cold, going for around 0 degrees Celsius or 40 more than 45 degrees Celsius, is very uncomfortable for the human being to live, okay, or to survive, to uncomfortable to survive, right? So this pattern shifts El Nino affecting rainfall globally. Winter Adley cell shift. In winter, the descending branch of the Adley cell moves to around 20 degree and to 30-degree north. This shift helps northeasterly wind transport fine aerosols toward the northern Indian Ocean. Okay, so you should supposed to know what do you mean by aerosols. So aerosols is nothing but you have a suspension of fine solid particles or liquid droplets in a gas, most commonly air. These particles can be natural, like sea salt, or volcanic ash, or human made, such as air pollution from burning fossil fuels. Aerosols play a significant role in weather, climate, and even human health. So, what does it mean is that the air particles, when it has been combined with the suspended particles, okay, whether it may be because of the air pollution or because of the volcanic eruption, that will have an effect on the wind, because of the it has been interacting with the atmospheric atmosphere. Okay, so this shift helps northeasterly wind transport fine aerosols toward the northern Indian Ocean. These aerosols can influence cloud formation. Understand? So the particles which are suspended in the air can influence cloud formation and regional climate patterns. Okay, early cell changes during El Nino. During El Nino, the rising branch over Asia weakens, reducing convection and rainfall in many tropical regions. The sinking branch over the Eastern Pacific also shifts, altering the global circulation. These changes can impact climate as far away as Africa and South America. So, early cell changes during El Nino. So, what does it mean actually? So, these changes can impact the climate as far away as Africa and South America. That's what they mean. Okay, so the western lights, clouds, and monsoons. The western lights overview. The western lights are prevailing winds found between 30 degree and 60-degree latitude in both hemispheres, blowing from west toward east, which I already told you in the definition. They influence weather systems in mid latitudes, steering storm tracks, and frontal systems. Their position and strength shift seasonally, affecting precipitation patterns over continents such as North America and Europe. Their position and strength shift seasonally, affecting precipitation, that is, rainfall patterns over continents such as North America and Europe. What is the ENSO events, which I told you actually? I will, within a few slides, I will explain you what is ENSO events. Okay, so the strength and path of the western layers can be influenced by ENSO events. During El Nino, changes in atmospheric circulation can shift the jet streams, altering the routes of storms and rainfall distribution. La Nino often strengthen the western layers in some regions, changing the frequency and intensity of mid latitude storms. So, as I told you, what is ENSO events? Okay, the ENSO events refers to the El Nino Southern Oscillation, a naturally occurring climate pattern involving periodic changes in sea surface temperature and atmospheric pressure in the tropical Pacific Ocean. Okay, there are three phases. One is El Nino, another one is La Nino, and another one is neutral. We'll see one by one. So again, I repeat, ENSO events refer to the El Nino Southern Oscillation, a naturally occurring climate pattern involving periodic changes. Okay, in sea surface. Okay, it's a natural climate pattern. Okay, involving periodic changes in the sea surface temperature and atmospheric pressure in the tropical Pacific Ocean. Okay, El Nino. What is El Nino? Usually warm sea surface temperature in the central and eastern Pacific weaken the trade winds, cause shift in the rainfall patterns, drought in Australia, heavy rain in South America. And La Nina, unusually cool sea surface temperature in the central and eastern Pacific, strengthen the trade winds. Okay, previous one is less than the trade winds, weaken the trade winds, now strengthen the trade winds, often brings opposite weather effect to El Nino. All right, so because it's the opposite effect, flood in Australia, drought in South America. Previous one is drought in Australia, now the flood. So just imagine, okay, one creates the flood, it's all natural means. Okay, these are all natural means. One strengthen the trade wind, another one is strengthen the weaken the trade wind. Okay, what is neutral? Obviously, it does not have any effect, right? No significance of El Nino or La Nino condition. Sea surface temperature are near average. What is the impact of this ENSO events? Changes global rainfall and temperature patterns, affects agriculture, fisheries, and disaster risk, influence the strength of monsoon and hurricane activity. Influence the strength of monsoon and hurricane activity. So catastrophe. Okay, these are also a natural things. Okay. Cloud formation basics. Clouds form when rising air cools, causing water vapor to condense around tiny particles called aerosols. The type and altitude of clouds depend on temperature, humidity, and air motion. Clouds are essential for the Earth energy balance, reflecting sunlight and trapping infrared radiation. And trapping the infrared radiation. Okay, very, very important. Okay, clouds reflect a portion of incoming solar radiation, albedo, and absorb the heat from the Earth's surface. Okay, their albedo varies between zero point 0.4 and zero point 0.8 depending on thickness, with cumulonimbus clouds exceeding 90% reflectivity. What do you mean by cumulonimbus clouds? It is a very vertical cloud. Okay, and it will have a strength. I mean thunderstorm and severe weather. Okay, I will explain this. Cumulonimbus clouds are massive, towering vertical clouds often associated with thunderstorms and severe weather. They are characterized by the dense dark bases and towering, often anvil-shaped tops. These clouds are known for producing heavy precipitation, including rain, hail, and even tornadoes. Okay, so this has happened because the formation goes like this. Cumulonimbus clouds typically form from cumulus congestus clouds, which are more developed stage of cumulus clouds. These clouds grow vertically due to strong updraft that carry moisture upward where it cools and condenses. When the cloud reaches the tropopause, the boundary between the troposphere and stratosphere, it can spread out, forming the characteristic anvil shape. Okay, so there are some few characteristics for cumulonimbus clouds. One is size and shape, color, weather. Okay, and it also have effect impact on weather, aviation, and other. Okay, so when I just share my experience because of the cloud. Okay, when the I usually in a decade became 6 years back. I usually for a decade I just usually travel on flight. Okay, where I could able to see a cloud. I mean, when they take off or a thing. Okay, if it will be a if you have a thicker cloud, it is very difficult for them to pass through, right? And also it's not visible. Even though the pilot could be able to, without seeing the thing with the latitude and altitude, they can move, but what is coming in the opposite direction, that also need to be known, right? Okay, so if it is invisible, they will go little bit higher or lower in order to avoid the cloud. Okay, So what I'm trying to say is that these also affect the aviation. Okay, if you have a thunderstorm cloud and also have the thunderstorm, what will happen if it comes and eat on the surface of the plane? Okay, well there is a lot of it could be able to withstand the thunderstorm in such a way that they would have built, but at the same time, okay, purposefully you should not go and eat, right? So I know the swimming, but I should not go and swim actually on the what you call where what you call the swirling takes place in the ocean. Okay, so obviously that doesn't work out. Okay, we can protect from the what you call natural things sometimes, but at the same time we should not go and against the thing. Okay, if the hurricane comes or catastrophe cyclone comes, okay, or the, what you call volcano eruption or what you call earthquake. Okay, what we need to do, we need to protect ourselves from doing that particular situation because we know already certain time it will come and then it will go off. Okay, but we could not go and against and play around with it, right? Understood what I'm trying to say? So natural things which happens need to be protected. So cumulonimbus clouds is nothing but actually is a very uh, broad cloud in the vertical direction. It contains thunderstorm. Okay, that's what the ultimate definition of the cumulonimbus clouds. Okay, it have different shapes, characteristics, and things like that. So how it forms that we have seen just now. Okay, so the cloud properties significantly influence the climate models and projections. Aerosols and the cloud effects. Aerosols can increase the cloud reflectivity by creating more condensation nuclei, resulting in smaller but more numerous droplets. This effect is known as two-way effect, can enhance the cooling influence of clouds. However, the complexity of aerosol cloud interactions make them challenging to model accurately in climate simulations. The complexity of aerosol cloud interaction make them challenging to model accurately in climate simulations. So the climate simulation you can be able to make it. Okay. So for example, in aviation, okay, aviation industry, the pilot will need to what you call uh, take care of the flight actually. Okay, when they fly, okay, the people will before they fly the real condition, they will give us climatic simulations, okay, in their simulator room, so that when the cloud is very what do you call it, the previous case which cumulonimbus, okay, cumulonimbus, okay, cumulonimbus. Please check the my pronunciation with the Google whether it's correct or not. Okay, so the cumulonimbus clouds, when it comes, what will happen if there is a vacuum? Okay, sometimes the jerk will be there. The jerk, if there is vacuum, the pilot will not go near to inside the vacuum. Okay, so this is all the conditions. Okay, so there will be jerk on the flight. This all happened to me. Okay, plus people should be very careful on while flying. Meaning to say, actually, need to see the climatic patterns. Okay, whether it can go or not. Even you could be able to see in India, I mean, especially in Chennai, when there is a rainy season, the flight might be cancelled because they could not, the pilot could not able to see the outside. Okay, that means the weather condition is worst. They could not, there would be visible view. Okay, the Indian summer monsoon overview. The Indian summer monsoon occurs between June and September, delivering about 80% of Indians' annual rainfall. So June, July, August, September. Okay, so 80% Indian rainfall is occurred during this monsoon. It is characterized by the seasonal reversal of surface winds from land to sea in winter, to sea to land in summer. It is characterized by a seasonal reversal of surface wind from land to sea in winter, to sea to land in summer. Okay, the system is important for agriculture, water resources, and economic stability in South Asia. Monsoon circulation features. The heat flow forms over northwest India and Pakistan by late May, drawing moisture from the ocean. The cross equatorial jet streams from East Africa bring additional moisture to the Indian subcontinent. High pressure systems such as Mascarini I and Tibetan anticyclone help drive the monsoon circulation. So, how the monsoon? What are the features of the monsoon circulation? Orographic effects and cyclonic disturbances. The Western Ghats and Himalayas force March air upward, causing orographic rainfall. Cyclonic disturbances such as monsoon depression and low pressure systems enhance rainfall intensity. Cyclonic disturbances such as monsoon depression and low pressure system enhance the rainfall intensity. Some of the system originate from the remnants of tropical cyclone in South China Sea. Have you think of why during the cyclone period this is a very heavy rainfall? Okay, cyclonic disturbances such as monsoon depressions and the low pressure system enhance the rainfall intensity. Underline the word enhance the rainfall intensity. Some of these systems originate from remnants, okay, of tropical cyclones in the South China Sea. Monsoon phases. The monsoon has stages: onset, active phase, break period, and withdrawal. Breaks involve a temporary reduction of rainfall over central India, which increases rain in the northeast and Himalayan foothills. Prolonged breaks can cause severe agricultural loss. Okay, so you should not have a prolonged break. Okay, global climate change, climate change and monsoons. Global warming is expected to intensify the rainfall during wet seasons in tropical and monsoon regions. However, climate models shows inconsistent results due to the uncertainties in simulating monsoon dynamics. Extreme rainfall events may become more frequent, increasing the flood risk. Extreme rainfall even may become more frequent, increasing the flood risk. So it should not be more drought, and it should have a more flood also. Okay, so the seasonal rainfall is okay. Okay, because otherwise it's very difficult. If it is very cold or if it is very hot also, it's not convenient for the things. But these natural things will brought everything. Okay, the cyclone, heavy rainfall, drought, and so on and so forth. Okay, aerosols and rainfall reduction. Volcanic eruptions can inject the aerosols into the atmosphere, reducing sunlight and cooling the tropics. Why we are studying all this? Have you think of why we are been studying this? Because the human made activity without any thing, this thing will happen. Okay, this is a natural means, but this because of the human made activities which will enhance, sometimes what will happen, will enhance, will changes the pattern of the natural things. Okay, obviously it will leads to a different drastic condition. Okay, that's what we are studying all this. Okay, so volcanic eruption can inject aerosols into the atmosphere. As I told you, aerosol is nothing but a air particle which has been filled with particles. It may be from the air pollution or maybe of volcanic eruptions. Volcanic eruption can inject aerosols into the atmosphere, reducing the sunlight and cooling the tropics. Okay, so this can weaken convection and decrease rainfall in regions such as South America and Africa. Anthropogenic aerosols have been linked to droughts such as the Shagel drought in the 1970s and 80s. Okay, so human-made aerosols, anthropogenic, okay, have been linked to the droughts. That is a natural. Volcanic eruption aerosols is a natural one that we could not able to avoid. But anthropogenic aerosols have been linked to droughts such as Shagel drought. What happened in 1970s and 80s in due to Shagel drought. Tropical storms and hurricanes overview. Tropical storms and hurricanes are intense low pressure systems that bring heavy rainfall, strong winds, and storm surges. They form over warm. The hurricanes usually common in Americas, not here. Okay, the cyclone is supposed to know the difference between the hurricanes and cyclones. They form over warm ocean waters and can cause widespread flooding and destruction. Their tracks and intensity are influenced by large-scale wind patterns like the trade winds and westerlies. Monsoon depression and cyclonic storms in India. The frequency of monsoon depression over the North Indian Ocean has decreased significantly over the past century. However, intense cyclonic storms during pre and post monsoon seasons have become more frequent. These storms can cause severe flooding and damage to the coastal infrastructure. Storm surges. Storm surges are abnormal rises in sea level caused by the strong winds and low pressure in tropical cyclones. Coastal regions such as Bangladesh, Ganga Brahmaputra, Meghna Delta, and Gujarat are particularly vulnerable. Okay, so storm surges are abnormal rise in sea level caused by strong wind and low pressure in tropical cyclones. So, because of that, water level is vulnerable, affected. Surges can inundate large areas, leading to a loss of life and property. Climate change is expected to increase the severity and frequency of extreme weather events. Regions such as China, Australia may face more intense floods, while others could experience prolonged droughts. Okay, so one area will be flooded, another one is affected with the drought. This all can happen. Okay, because of the climate. Okay, water management system must adapt to these changes to protect communities. Implication of policy and infrastructure. Policymakers must plan for future climate extremes when designing infrastructures. This includes stronger flood defenses, improved drainage systems, and better cyclone shelters. Integrated water resource management will be crucial for climate resilience. So, what I would like to conclude in today's lecture is that global wind system distribute heat and moisture. Okay, underline the word global wind system distribute heat and moisture, influencing climating worldwide. Okay, influencing climating worldwide. Global wind system distribute the heat and moisture. Okay, influencing the climate worldwide. Trade winds, early cell, and western ice drive major weather systems like monsoon and storms. Okay, drive major weather systems. Because of these three things, drive the monsoon and storms. Okay, and climate change and aerosols are altering these patterns with a significant implication for water resources and disaster preparedness. So with this note, I stop it here. Hope you understood today's lecture, the importance, okay, how it has been related to the global climate. Okay, I stop. We will see in next class on face-to-face section on Wednesday. Thank you.